this experiment, you need to find out what mass you need of the CuSO4 to make your stock solution. Then you need to find the concentration of each of the dilutions you will be making. After you prepare each of your dilutions, you will then begin putting your dilutions into cuvettes to test in the spectrophotometer. The first cuvette you must prepare is a cuvette full of water. This is your blank to put into the spectrophotometer. Use pipetting techniques to put the dilutions into the cuvettes. Notice how she continues to fill the cuvette until the meniscus of the solution is at the faint line at the top of the cuvette. Continue placing each of the dilutions into cuvettes until they are all into cuvettes, including the original stock solution that you started preparing your dilutions out of. At this point, you should have 6 filled cuvettes, 1 blank, 1 with stock solution, and then your 3 diluted solutions, as well as your 1 unknown solution. You must then take your cuvettes to the spectrophotometer in room 360. The first thing you should do when there is place your blank into the spectrophotometer after you wipe the 2 sides. Then use the programs on the computer to zero these programs to make sure that the absorbances you record for each concentrated solution are accurate. When you are sure the programs are zeroed, remove the blank from the spectrophotometer. After the program is zeroed, begin testing your solutions. Be sure to close the spectrophotometer completely and then use the program to read the absorbance. Record this absorbance in your lab notebook. Once it is recorded, remove the cuvette from the spectrophotometer and close the lid. Then repeat this procedure with your stock solution cuvette, each of your dilution cuvettes, and your unknown solution cuvette. Make sure to record the absorbance for each concentrated solution in your lab notebook. Once you have them all recorded, make sure to clean up and make your table look a little nicer like this one here. Before finding the specific absorbance of your concentrated solution, you must find the lambda max in the first program. The lambda max is the wavelength at which the most light is absorbed by a particular solution. We must scan across all wavelengths to find our lambda max to be able to represent the most accurate absorbance within our concentrated solutions. The lambda max is found at the highest peak on your graph of wavelengths. Once you've recorded all your absorbance and concentration values, you can then evaluate the relationship between absorbance and concentration. This relationship is known as the Beer-Lambert law. Concentration is defined as how much solute is dissolved in a solvent. The absorbance value is how much light is absorbed when a light beam passes through the solution in the spectrophotometer. As you can see, this relationship is a direct linear relationship in which when absorbance or concentration increases, the other increases as well. Once you understand this relationship, you can then calculate the concentration of your unknown solution. You can do this by using the formula C1 over C2 equals A1 over A2. Use a solution that you know the concentration and the absorbance on to compare it to the absorbance of the unknown solution to find the concentration of your unknown solution. This is why it is so important to zero the program before you use it, because if not, your absorbances will be incorrect and you will no longer be able to calculate the correct concentrations. Always remember to practice good lab safety habits like wearing your goggles and wearing the correct attire. Also, don't forget to clean up your station once you are finished and return the cuvettes back to the lab to be cleaned and washed out and returned to their places.